In this video class, we want to start working with indirect measurement, which is really a fancy way of saying we're going to work with triangles, similar triangles, in order to solve problems. So let's take a look at the first example that I provide. Here we have a tree and a man. We don't know how tall the tree is, but we do know that the man is 6 foot tall. Well, knowing how tall the man is, not knowing how tall the tree is, doesn't allow us to solve the problem. So we need some other consistency between the tree and with the man, and introduce the sun to solve this problem. You'll notice here at the bottom, or at the top, we have a nice little beautiful sun here. Can't you see this tree? It's awesome. And the happy guy over here who's 6 feet tall. Someone else is going to measure the length of their shadows. And so these dotted lines are just, think of the angle of the sun, and this is going to be the tip of the shadow measured from the base of the tree. Now we're making some assumptions on these kinds of problems, that the tree is growing at 90 degrees to the ground. It's a perfect angle, which we know doesn't always happen. And this man is standing at 90 degrees to the ground. So we are making a few assumptions, but in general, if you were to do something like this out in your yard, you're looking for something that's close, something that's very approximate. We're not, again, as I've said in class, we're not launching missiles this way, but we are getting something approximate, very close. And so anyway, this shadow is measured at 12 feet, and this shadow of the guy is 3 feet long. Now, there's a couple of ways that we can do this. One is to create proportions using ratios. Another way is to use a scale factor. Why don't we look at the scale factor? So we'll just call that method 1. Method number 1 is a scale factor. And the easiest way to do this is to think about what direction you want to go. So the easy math would be to go from the guy's shadow to the tree's shadow. And I would ask the question, how do we go from 3 to 12? Well, we have to multiply by 4. But you know that golden rule of algebra that we've talked a lot about. So if I'm going to go from the base of the triangle, 3 to 4, then the height of the triangle has to go, not 3 times 4 is what I should say. From 3 to 12, we multiplied by 4. So that means I'm going to say 6 times 4 equals 24. And so the height of the tree is 24 feet, just using a scale factor. All right, what about a method number 2? What if we used, let's just say method number 2, and let's use proportions, and let's see what happens here. So method number 1, scale factor. Method number 2, proportions. And this is where we're going to compare parts of the triangle. And it's always good, it's always helpful to think about direction. And what if I were to name these triangles, if I were to name this one A and this one B. And so the first step is to define your path. And I'm going to go from A to B. And that really tells you how to fill in your two ratios. And you're going to have two ratios. It's going to look like this, and we're going to set those equal to one another. So if I were to go from triangle A to triangle B, let's start with our height. And so if I put my height in as for the top of A, then I'm telling myself I have to go to 12. Actually, let's check that real quick. Just thought about that as I said it out loud. If I'm going to measure the height from A, then I want to go to the height to B. And that's what I'm doing right here, defining my path. I'm going from A to B. So if I start with H in my numerator, and that's the height of the triangle, which it is, then I want to compare it to the height of triangle B, which is the height of the man. So with that said, if I did the height of my first ratio, then my second one, I'm going to go from 12 in triangle A to 3 in triangle B. Now, we could even use a scale factor again to solve these, or we can cross multiply. It's a proportion, so we can cross multiply. It's going to be 3 times H is 3H. 6 times 12, that's 72. We're going to divide everything by 3, and you get H is equal to 24 feet. So again, two different methods. You can use a scale factor, or you can use proportions. I would encourage you to know both. Ratios and proportions are going to really help you as you move through algebra. And just as a side note, the ACT and the SAT, they love using proportions. And so they can really help you solve problems quickly on both of those tests. So I would encourage you to pause the video and let's try these practice problems. And after you've tried them, restart and see if you got them correct. All right, on this problem on the left, we have given you a building with an unknown height. And once again, I'm measuring shadows. And here I have on the left, we'll just call this a meter stick. I have affixed a meter stick 90 degrees to the ground so that I could know a height and measure the length of the shadows. And so let's use, why don't we just use proportions to start off with. And let's say this is A, and I do think it's helpful to always number them. And then you can define your path. We're going to go A to B. And why don't we do the base first? So if I do the base of triangle A, then I need the base of triangle B. And I really should have drawn the B here and not there. And so let's set up our other ratio. If I did the base of triangle A, now I have to work with the height of triangle A. And if I work with the height, then I have to do the height of triangle B. And I can cross multiply here and get 2h is equal to 10. Divide everything by 2 and get h is equal to 5 meters. H is equal to 5 meters. You could also use scale factors to solve that problem. Going from 2 to 10 would be times 5. And so that would mean I would multiply 1 by 5 and get h equals 5 meters. Either way works, and I get the same answer. So go ahead and pause the video if you haven't already and try this second problem. All right, when we come to the second problem, I hope you can see that there are actually two triangles. There's the larger triangle, ADC, ADC, and there is a smaller triangle, AEB. And they're overlapping. That tells me that this angle is the same for both triangles, but the height is going to be different. But I'm also know you can see these double arcs here. That tells me that angle ABE and ACD are also the same. And I know the overall height here. Another thing they gave me was the long AD of the triangle, but then I know this distance, just this small distance between E and D. So with all that said, I've just kind of reviewed what we have. I know that this triangle, this portion of this triangle is going to be 18 feet. I simply subtracted the 2 feet from the overall 20 feet, and now I should have everything I need. I'm going to label this triangle A and this triangle B. Now the B triangle, it's not just this section, it's the overall triangle ADC. So let's define our path. We're going to go A to B, set up our proportions, and why don't we use the base? Let's use the base of A over the base of triangle B. Let's use the height of A, which I do not know. That's what I'm looking for. And the height of B, which is 2.5. We will then cross multiply. So we're going to end up with 20h is equal to 45. 18 times 2.5 is 45. We're going to divide everything by 20 and get h is equal to 2.25 feet. So it's not much smaller, but that makes sense that it should be smaller. So you also want to use some logic here. Always use logic in math. What if I got 2.75? What if I did a little miscalculation or I read my calculator wrong and got 2.75? Well, that wouldn't make any sense, would it? Because I have 2.5 here and it has to be smaller. So I always want to use a little logic. So again, I use ratio and proportions. You could use your scale factor. For me on this one, I'm not so inclined to use a scale factor because of the decimals. It's not an even working number. Like this example here was, I'm just going to multiply by 5. The scale factor is the quickest way to solve this problem. But a problem like this, I think you're better off using your ratio and proportions. So you're going to have to make that decision as a mathematician. And guys, if you have any questions, send them my way. Thanks.